You're muted.
I'm on mute. Okay. Woo. I was talking away. Why didn't someone tell me something? Group 1, Fidel, Leslie, Michael, Vanessa. How far did you get? Did you get through these?
I got halfway up to 13. I'm not sure about number 3. Someone else knows.
Okay. So what are we trying to grab from the table? What does it say? Find a formula for a linear function. So if we think about a linear function,
We need to find this.
I hope the first thing that pops into your mind is like this equation, right? That's my
Yes.
line. That's the equation of the line. If I want to do function, it looks very similar, except I do maybe like f of x instead of y.
4 and x.
Mx plus b. I think the other thing they might say is, do they do the ax? Sometimes they do the ax for your slope. I don't know if we're getting in that sort of direction. They might start doing ax plus b. It's the same thing. We're looking for a slope. We're looking for a y-intercept. So how, first thing, I need a what? Slope. How do I find slope from the table?
Yes.
0.03.
That would be
Y-intercept.
that would be my y-intercept.
Sorry, what was the question? Oh, the slope. Sorry.
That's fine. So does everyone see how that is the y-intercept? So what is my intercept? My y-intercept is when the x is 0. So if we looked at this, if we wrote this out as a point, we could also write this out as the point 0,3. My x is 0, my y value is 3.
Mm.
So that would be my y-intercept. The question was, if I want to find my slope, how do I find a slope from the table? We did this like last time, right? Something very similar.
I think we need just to pick up 2 points in the table and
We
find
should
the
look
slope.
at 2 points.
Yes.
We should look at probably here just to make sure that the slopes are matching up. Because that was like what, 1.4 where we did that?
Yes. No, 1.4, 3.6.
Yeah, it was the last thing we did, I believe, right before the test. And so if we come here, I believe we're going up 2. I believe here I'm going up 4. So I want to make sure that my slopes actually match. This thing is really linear. That was a homework problem from And I think we go from 4 to 3, we're going down 1. If we go from what 3 to 1, we're going what down 2.
Mhm.
So I'm counting how many up, how many down I'm going. And
Yes.
now's the part where I think a lot of people mess up. So slope is
The raise over run.
rise over run. So if you can remember rise over run, y's over your
Wait.
x's.
Yep.
How do I need to write this thing?
Can I answer?
I see a 2 and I see a -1 there. Well, what order do I write those in? That's the next thing, right? I think
Mhm.
this is where they mess up. Which one's my rise? Or y's?
Minus no, 4. 4
Is it the
You're right,
-1 or is it the +2?
-1 is
It's the
your-
-1. So that
Negative
-1 has to go on top. The 2 goes on the bottom. So I think when they pull the slope off the table, a lot of times people like forget to flip. The y's go on top, the x's go on bottom. And if we look at that, I think that should be the same thing as what -2 over 4 should be the same number. We're going to go with probably the -1/2 because that's the simplified version. But just doing like a sort of check, we want to make sure that our table actually lines up and that they are giving us something linear. They kind of told us it was linear here, so we didn't really need to check it. But we can check it. We have the technology. We have the knowledge.
Teacher,
Okay.
excuse me, is it correct they just pick up 2 points in the table and then I find my slope and I
Yeah,
didn't.
for here, that's probably all right because they tell you it's linear. If they're asking you
Yeah.
to check if it's linear, you want to do every point to make
Okay.
sure it doesn't go off at some other point. Like one of those points isn't off over here, making it not linear, right? It needs to have the consistent slope.
Mhm.
Here, we can probably assume that it's going to have a consistent slope since they tell us it is linear. And so I think I got a lot of information on this table. But I think that's the pertinent information I need to write my equation. So if we're doing y equals mx plus b, what am I filling in? My slope is what?
Y2 minus y1 equals to x2 minus x1.
Ooh,
Then you are what I did. Then I pick up 2 points in the table. I find my slope equals to -1/2.
yeah, we actually did that when we did it in the table. So we have our slope is what?
-1/2
-1/2.
plus 3.
What? It's -1/2.
Make sure I
we
got
need
my
to
negative in
find
there.
b.
They're probably going to have what? Instead of y, if they want the function, is that what they're saying? Yes, they want a function. So instead of y, they might write f of x to make it a function.
Yeah, -1x, -1/2x plus b.
And of all of those, how did you, oh, because you added the -1 and the -2, and that gave you 3 as your y coordinate? Is that how you got 3? Because I'm trying to figure out how you got 3.
3 came from the y-intercept here.
Right, so you did -1 plus -2, which made it +3, +3.
So the 3 comes from this point right here, which was our y-intercept. So our
Oh.
y-intercept is when our x variable is equal to 0. We're looking at that point, 0,
Well,
3.
why not choose 4 then? Because it's on the y-intercept also.
Which one? -2, 4?
Yes.
That is not a y-intercept because our x value is not 0. That's going to be off on the left somewhere. It's not going to hit our y-axis.
So because you have -0, you have to go to where the 0 is in the X value.
Yeah, to find the y-intercept, it's always the y value where your x is equal to 0.
Okay. All right. So if it was -2, then my y value would have been 4.
So in this notation right here, right, the b is your y-intercept. So you're never going to pick
No,
off.
no. I'm talking about on this graph. Because you have -1/2 x plus 3. But what I'm saying is you saying that on this graph, the 0, which is this x, and the f of x is b, right? Which is the y, which is our y source, right? So if it was negative, so the when you found the slope form is -0/2, right? So if it was -2 instead of -0, would the bottom part of the slope been 4?
So the 1/2 is coming from the difference between these two things, right?
Right.
That's where the -1/2 is coming from. So I'm not really sure I follow what you're asking.
Teacher, excuse me, she's asking about when y equals to -2. Is it
Yeah, I'm
correct?
trying to
X
figure
equals
out
to
how.
4? Yes. Yeah.
I mean, because if looking at the chart, I could have put anything. I mean, I could have chose. I'm trying to figure out how to choose the right form, how to choose the right numbers on this graph. Because if you had, I mean, I know that you had here, it was from the -2 to that you said it was +2, which makes it 4, right? So did you, in order to get that, in order to get -0/2, did you add anything, or you just looked on this graph, right? And said the 0 is 0, was it 0/2?
0.3.
Right? -1/2. But if you have this 3 right here, why isn't it that I couldn't go -1 plus -2 and come up with +3? Would that have been wrong?
-1.
Because when you first did the graph, right?
I don't
What
see
I'm-
where you're getting the -1 plus the -2.
Yes. But you're looking on the chart, right? You're looking on the chart and saying 0, which is the x value, and 3, which is the y value, right?
Mm-hmm. This is giving me the 0.03, which is a y-intercept.
0.3, right? So why not? How come I couldn't choose -2 or to 4?
-2,4 is not an intercept. That does not hit my y-axis. -2,4 is somewhere like over here. It's not on my y-axis. So in my form, I want my y-intercept. The b
Okay,
here
so-
is the y-intercept. It's something in the form 0, b. So this does not have a 0 in the x.
And then you flip it, right? So you put
So this does not have a 0 in the x. So I cannot pick any other point besides a y-intercept.
Because each time you have y-intercept, you need to find the x equals to 0. This one is always when you have the y-intercept, x equals to 0, and x-intercept, y equals to 0. Right, teacher?
Yes, I think so. I think you said that right.
Yeah.
Yeah, so it has to be the y-intercept. There are other points on that graph. They are not y-intercepts. And so
I'm not sure that I fully.
I can explain that more, but that is like that's older material that we've gone over. a few times already. What's next? 7, 8, 9, and 10.
Excuse me, teacher, the equation in this exercise for number 3, it's -1/2x plus 3, right?
Yeah, that's it. F
Yes,
of x.
Can I just make sure? Thank you. You
F
can
of
move to
x.
the set.
Okay, so we have 4 different equations. 7 says the height of the Empire State Building from those dates, the average cost of a new car, distance between a runner in a race and the finish line, and the amount of money earned after X hours when working at an hourly pay rate. Who's next? Leslie, are you around?
Yes.
All right, did you get, whoa, where did my share go? All right, so the height of the Empire State Building, how did that change from 1990 to 2010?
We were just supposed to pick one of these graphs, right? That
Yeah, so which graph did you choose?
I wasn't really sure. I picked A, but I wasn't really sure.
So the height, if you think about the height of the Empire State Building,
Mm-hmm.
how did that change?
I don't know.
Maybe that's a trick question, because why?
Yeah, I'm not sure.
Did it change?
No.
No, it's the height of a building. It didn't change. So which of these graphs tells me that didn't change?
D.
D is exactly the graph. This one, I believe, is D. Average cost of a new car from 1980 to 2010. So how did that change?
I got C for that one.
The cost of a new car. So they're saying every year that not the same car, because I thought the same thing. Does that make sense?
I would say B.
Yeah, I
because
think it's B.
started out at a certain
Yeah.
price and just increased.
If they were talking about the same car, C would probably be correct. But they're talking about different cars. We're just going to a lot and we're looking at what the price of a new car is going to be. And so this one, I believe they're going to B. Why not A? Because A starts where?
At 0.
At 0, and that would imply a car is free. I don't think they're
Free.
giving. Don't think I've fallen for that ad one too many times now. They're not giving away free cars. What is next? Distance between a runner and a race and the finish line is which one?
C.
This one is C. So we're gonna start far away from the finish line. And as we run, we're getting closer and closer to the finish line until I think right here we hit the finish line. Is what this is telling me. And D is amount of money earned after X hours when working. There's only one left. But can we see why, like maybe this one would be A? If we don't work at all, guess what? We're gonna earn $0. That's what this tells me. And then as I work, I'm going to earn more and more money.
Likewise, yeah.
Reminded of those Dimitri Martin graphs that he has. They're just trying to get you to look at these things and think about these like basic shapes. We're thinking about what? Slope, which is the rate of change. And we're thinking about the y-intercept, which is where you're starting, your initial start point. So if we think about the height of Empire State Building, it's not going to change. 8 is the cost of a new car. So we know they're not giving away cars, so we can't start on the 0. We're starting at some number, and it's just going up. Price of new cars are just going up. The next thing is what? Distance between a runner and the finish line. We're starting away from the finish line and we get closer to the finish line and we hit the finish line.
You mean B is 8, right?
So 7 is D, 8 is B, 9 is C, and 10 is A.
Okay, thank you.
Amount of money after earned X hours, well, they're not going to pay you anything unless you start working, if you're working hourly. And then we're just going up from there. I think the first thing you're probably asking yourself on these is like the slope. What is the rate of change? And the second question to distinguish like what A from B, you probably need to know where you're going to start out. Oh, wrong device. I'm trying to scroll on. Okay. Questions about these? Do these shapes make sense? Hopefully. Okay. 13, 19. Don't get this far. I think some people said they got to 13. I might give y'all some more time to do 19 and that other one, 23, wasn't that? Did anybody get 19 and 23?
No.
I'm seeing a bunch of like no's and nods. No.
Can you just go over 13? Because I didn't get 13. I'm thinking that they wanted us to identify if it says identify the function, the linear function that models the situation. So, or are we supposed to actually state that it was a point slope, or is it the point slope?
It should be
Form?
slope yeah, it should be slope intercept.
Slope intercept.
So we're looking for something.
The slope intercept, which is x2 minus x1 divided by
Slope intercept.
y2 over x1 divided by x2 over x1.
So slope intercept should be the one with the slope, and the intercept should just be the mx plus b. So we should end up with some kind of formula that looks similar to mx plus b, something like that. And the first month of 2016, what are we doing? 0.6 trillion text messages were sent. The number of text messages being sent and each month during 2016 grew by 0.08 trillion per month. So we want to write some sort of formula, some sort of function to represent this. And so what would my x variable be? What would my y variable be? What are y'all doing? And it doesn't have to be x and y. It could be any variable you want. So maybe I should ask you.
Text messages and the month.
X equals what? Number of text messages?
Yeah. Yes.
Per month? I think you're giving me something.
No, I think it's the opposite, teacher. I want to say like the x's is the month and the y's is the text messages.
Okay. So X is the number of months and Y is the number of text messages. I think you're giving me the units on slope for a second there. So X, if we read this, if you have a time, like almost always, right? When you're doing this thing, like your X variable is going to be your time axis,
Yeah.
right? Almost always, if there's a time sort of element, your X variable is your time. So if they're giving you a time, and we look at the time here, my X variable is what, months?
Yeah.
Yes. And then
And the thing that we're recording per month would be the other variable. So my f of x They want a function, linear function. So my f of x or my y variables would be what?
The
other-
number of messages.
Yeah, the other thing we're measuring here is number of text messages. The number
In
of
this
text.
case, teacher, like the function, it's going to be like the mx plus b. The number of the text messages is the b. No.
So this, and we've used it, it's my rise over my run. If I'm talking about a word problem, we've used that word. It's the rate of what?
Change.
It's the rate of change. So if I know what the rate of change is,
The rate of change is the text messages per month.
yeah, they give us that. They give us that in the problem. And then what would my B be? Like if I'm talking about in a word problem, it's the y-intercept. Like what does that mean in context to the word problem, like in that previous graph? Like our y-intercept when we were buying cars, it wasn't 0.
Yes, the
Where
x
was
equals 0. Yeah.
The
It-
0.6 trillion.
Probably, yeah. I was looking for like a more general sort of thing happening. That 0.6 trillion is where we're starting, right? So this is like our starting point.
Like he said,
Initial-
the first month, excuse me, the first month on 2016 is 0.6 trillion.
So that would be the 0.6 trillion that we're plugging in there. So the B or the y-intercept should be some sort of initial amount, starting amount. And then the M or the slope is my rate of change. So those are the two things I'm filling in. So I believe they say we're starting with 0.6 trillion text messages. And then it's
You
growing
measure
by
the rate.
0.08 trillion per month. So I know I wrote a lot of stuff down. Let me delete where I define my variables. So X is number of months. My Y or my f of X is the number of text. So if I want this thing, f of X equals mx plus b, we talked about the rate of change. It says it's what, 0.08. And is that positive or negative? I guess is the next thing you gotta ask yourself.
It's
Is it going
positive.
up? Is it going up or going down? It is going up. And I'm cramming it here. But I need a plus 0.6. Is that what it is?
Hmm.
Starting amount 0.6 trillion.
Yes, 0.6 trillion.
And I said this was the number of
It's
text.
grown by 0.003.
Yeah, I should really say this is the number of text. TXT. And I should really say that this is in trillions, right? When I define my variables, I know I deleted it already, but I should really specify that that is the number of text messages in trillions. Unless you want to add those zeros to your equation, which I would not personally do. I would just probably just tell them, hey, that's in trillions. It's a lot easier to put those two words on there.
Teacher, here you mean the 0.6 trillion is the rate, right?
So the rate was 0.08. We're getting 0.08 trillion per month. And so we get something like f of x equals 0.08x plus that 0.6. All right, so I think I'm gonna give y'all like 5 or 6 minutes or so. Not quite as much time as I gave y'all. To do those other two right quick. 19. And what, 23 was the next page? 19 and 23, I'm gonna give y'all a few minutes to work through those before we come back.
A quick question.
Yeah.
What the hell does C mean?
On
It's just
what,
a
19?
gears. 19.
I think there's like maybe some kind of picture that didn't get generated. But it just
Okay.
says graph the function and identify and interpret the intercepts.
Okay. Gotcha.
I think that's what we're going to end up doing on there. I don't know. I'd have to look at the book to see what it was, to be honest. I think it's a picture that didn't generate. Got rooms. I'll put it back in about 5. I'll leave. Oh, I'm recording again. Okay. So I think I'm more around room 2, Diana, Jade, and Sage. Number 19. So write a formula for a function W that gives the number of gallons of water in the tank after t minutes. So I know I have f of x equals mx plus b, but I just wanted to go over this. They want us to use, instead of x and f of x, what, t and w? So I don't know if this is what might be tripping you up. But they might want something like in this sort of form, right? Something times t, and then we're going to add a constant number.
Doesn't T equal 7?
In part B. So we're in part A.
Yeah, I just realized it wasn't connected. Sorry.
Yeah. So we want to think about what these things are. So if we think about our slope, that is like our rate of change. Our B is like our y-intercept. It's like our starting value. So if I'm thinking about my slope, I know we have a 300-gallon tank, and it drains, what, 10 gallons per minute? Which of those numbers is my rate of change?
The 10 gallon.
T.
The 10.
Oh, no.
What is 10?
And what's something that like gives a rate? There's a word there that really like tells you this is a rate.
Yeah, they said the rate of change, the rate is 0.01 gallons of minutes.
2 minutes. It should be 10 gallons per minute. That's what the problem says. It's draining at 10 gallons per minute. And so it is 10, and there is a what, T attached to this thing? Anything else about that?
Shouldn't the 10 be negative?
It's got to be negative. Why is it got to be negative?
Because the water's draining.
Because it's draining. It is leaving. We want to represent that it is leaving, that it is draining. And so I get this minus 10t from my rate, and I have to add the amount that the initial amount, the amount it started at.
300.
So I'm adding 300. Is this 300? Is that positive or negative?
Positive.
Positive.
It is positive. We have that amount. We have that amount. We're losing that amount. So the 300 is positive. That negative 10, that 10 should be negative.
You mean negative 10 times 10t plus 300, right?
Yep, that's it. And so the other thing is, like I said, that minus 10 was my rate. What is the word that really gives the way that something is a rate or something's a slope?
The gallon by minutes.
I'm trying to get y'all to notice this thing. What does that say? It says gallons per minute. What does that mean?
The change.
Yeah, that indicates the rate of change if you say per. But what does that word per mean? Like what is the operation mathematically?
By, over.
It's divide. You're about dividing stuff. You're
Yeah.
dividing your y's, divide x's is what this tells me, right? If we look at the unit on our y's, it's gallons. If we look at our unit on our x's, it is minutes. W's and T's maybe. W divide T. Okay, same thing. The unit on our W is gallons. The unit on our T is minutes. So the thing that tells me that this is my slope or my rate is that word per, right? If you see that word per in there, I can almost guarantee you that thing attached to it's probably going to be your slope. That word per is telling me it's a rate. I get gallons per minute. I get miles per hour is the rate that I'm traveling down the road. Speed. Questions about this? This is a lot of vocabulary, huh? Okay. Okay, so if you did it with f of x, this is okay. You understand the concept. If it was like the w of t thing, was throwing you off or something, that's not the end of the world, right? That's a little bit of notation stuff that you can get down. That is doable. The thing is that, like, I want you to know that that -10 is your slope. I want you to know it because that's the rate. I want you to know that 300 is the amount that we're starting at. So this is my function. We find the formula. Now what do we do? Who was answering him before? Was it Sage or Jade? I didn't see you. So I get this from part A. What is part B telling me to do?
The time when the time is 7 minutes. We need just to
Plug-
change it with 7 minutes.
Plug in 7.
Plug in 7 to where? There's 2 spots I could plug it in, right?
T, yeah.
So this is saying t equals 7. So when t equals 7, we want to know what is my w, or w of t, I guess I should say, just so I come on notation. Or I guess we could also call it w of 7, right? We want to know what this thing is.
Yeah.
So what does that look like? So the important thing is you're plugging in the 7 into your
Minus-
t, right?
Yeah.
So I don't have a lot more room, so I'm going to end up erasing stuff I'm using. But there's my formula. Now my formula's gone. But there is my formula with the 7 plugged in. So this is what? -7 times 10 gives me what? -70 plus 300.
Equals to 230.
Okay. If you did this, this is okay. But this is 230 what?
Gallons.
Gallons. But we do want to put some sort of units on there. If this was a problem and they didn't tell me to interpret it, that's probably okay. If this says something about interpreting, I want some English sentences on there. Some sort of English sentences written out. So if this was said interpret, let's say it did say interpret, just so we can get some good practice.
It's increasing by 230 gallons by minute.
So what does this
No,
say?
it's decreasing, sorry.
Okay, so we have T is 7 minutes, right?
Mhm.
We know 7 minutes and we know 230 gallons. So can you give me a sentence with those two things?
After 7 minutes, the it's decreasing by 230 gallons per minute.
Ooh, not really close. So after 7 minutes,
The tank would.
yeah, so this is the total gallons in the tank. It's still decreasing by 10 gallons per minute, but after 7 minutes,
The tank would decrease to 230 gallons.
yeah, the tank decreases to that, right? The tank is at 230 gallons. I can put in a time and I will get a specific amount of gallons out of that. That's what that function is telling me. Graph W and identify and interpret the intercepts. How long, oh, let me ask this question. How long would it take for this thing to be completely empty? Did y'all figure that thing out?
It's 1T equals to 0.
'Cause that's what we have to figure out for this next thing in order to figure out our axes.
30 hours, would it not?
30, I think it's minutes here, yeah. But yeah, it would be 30, right? So if we wanted to, W of T equals what, minus 10T plus 300. If we wanted to figure out when this thing was drained, I think we could set the gallons equal to 0 and figure out the time was one way we could do it probably. Solve this thing for T. So this isn't a question that they asked, but
It's 30 minutes.
yeah, it should take 30 minutes for this thing to be completely drained. So that might be a bit of good information to maybe pick off of there. You can go back and check it, right? Minus 10 times 30 plus 300 will give you 0. I wanted to check it. I don't have enough room to write the whole thing up there. Okay, but it should be drained after 30 minutes, I think is the number I'm looking at. And so if I want to draw a graph to represent this, I have an X, I have a Y. And so if I'm working with something in like reality, I know that I'm not going to go to what, negative gallons. I know I'm not going to go into negative time. So I can kind of assume like this thing is going to be all in the first quadrant. Most of reality happens in the first quadrant, right? We usually don't have negative hours. Depending what we're measuring, we usually don't go to negative stuff. Like in this example, we're not going to say the tank has a negative 10 gallons of water. That doesn't make a lot of sense. What does that mean? It's going to suck up 10 gallons of water or something? I don't know. And so I want to think about this. My x-axis is what?
It's the hours.
Minutes.
It's the t. It's actually your t-axis here, I guess, right? T or time in minutes. And then this thing is the y or the, I guess, maybe w-axis here.
Gallons.
And
Number
this
of
is the
gallons.
gallons of water. And so I want to just draw the axis or the intercepts. I think that's the easiest way to get this. This is my 0 right here. What is the most amount of gallons I need to put on this thing?
300.
300. So starting at 300, is it ever going to get more than 300?
But teacher, excuse me, when they said after 1 minute, we have after 1 minute and after 7 minutes.
Yeah, you can graph the 1 minute, right?
Yeah, when we graph
As a point, 1 comma, what was it? Or it was 7, no, it was 7 comma 230 is also a point, something like that. So that should line up. I'm not gonna draw the graph probably the most accurate on this one, if I'm being honest. I'm trying to get certain information on here. And so if we do just the intercepts on this, I think that would be pretty descriptive for this. So we know it's going to go 300 gallons. We know it's not going to go up from 300 gallons. So 300 gallons is the most. How far out are we going in time?
30.
30
30.
minutes. And what do we know about 30 minutes?
It's going to be down because the rate is negative.
It's gonna end.
0 gallons. So that tells me there's a point here. I'm also starting here. Can you imagine what this thing might look like?
A line going down.
It looks like a line going from that intercept to that intercept. So that
Yes.
tells me I have a tank that starts at 300 gallons.
going
It's
to be
draining
down.
what, 10 gallons per minute over 30 minutes until it gets to 0.
We have as this the same question in the test, right?
There might have been a similar question.
It's not the similar because in the test it's, the rate is going up because it's a positive. Here it's negative. Yeah.
And it says identify and interpret the intercepts. So I kind of said it. I'm going to say it one more time. I'm probably not going to write it out, but you should definitely write it out. The intercepts, right? The 0, 300 would be my y-intercept. What does that mean? That means at time 0, I have 300 gallons. That's what that means. So when the time is 0, my initial starting point, this tank starts at 300 gallons is what this tells me. The other thing I have here is what, 30, 0, my x-intercept tells me at time of 30 minutes. That is a 0, not a 6. 0. Okay. I have 0 gallons in my tank left. Find the domain of W. That's like, oh, it's right there. 0 to what, 30? And I believe we include both of them.
The domain, yeah, 0, 30.
We already found, we pretty much already found the domain when we did this, our graph. So we're not going past 30 because we're going to be talking about what, negative gallons in our tank. Then it doesn't make sense to our models.
What was the domain?
The domain is, it's one of those things that's implied within the word problem itself, right? We're not going negative, so we're starting at 0. We can plug in 0. We can plug in 0 minutes. That's a fine, right? We can't plug in negative minutes. We can plug in 30 where we'll be at 0 gallons. But if we try to plug in anything over 30, like 31, it's not going to make sense with this model because it's going to start giving us negative gallons. So this model only works from 0 to 30.
Close bracket.
Yeah, close bracket on both.
Yes.
So
Okay.
we're only working within the first quadrant, right? We have those sort of restrictions of reality. Reality is only sort of happening in the first quadrant. Okay, we got a few more problems to get through.
And excuse me, and the range here, it's like 300, no. Yeah, 300, 0.
Flip those and you're there. Start with the low, go with the high. So 0 to 300.
0 to 300.
That's it.
It's the
Do they ask that? Is that one of the questions? No, they don't, do they? That is a good question. Okay, so where are we at next? I believe, what is it, 23 was the next one? It's pretty similar to this one, except you don't have to draw a picture, right? I want to go 27, 29, 33. I want to go through some of these because we're going to need to go through some that are piecewise for sure. Let's go through. I got it here. 27 looks like a pretty good one. I want to go through 27. 33, 34, 35 are matching. We can do that right quick. And then I want to go through one that's drawing the piecewise. So I want to go through 49, I think. So what did I say? 27.
I said 27.
I want to do 27, 33 to 35. And then the other one, the last one, I want to do one of those graphing ones. So let's go with 49. 49 or 50. Let's go 49.
I have a quick question about 23. Are you okay with us using decimals at this point, or do you still want us putting everything into fractions, like whenever we're writing these equations?
Let's see. 23. If they're
It
giving
gives all the-
decimals, you could
Yeah, they're
probably give
giving nothing to
decimals.
decimals. Okay,
Yeah, I would put everything in decimals in there.
cool.
If they're giving decimals, I would probably do decimals as well. That's fine. It's usually when your decimals rounding is when you want to stay away from it. If it's like 1/3 or something. But even with these word problems, sometimes it's better to round it and to give you. Because your boss, if your boss asks like, how far is this? And you tell them it's like 1/3 of an inch or something, that is a little bit weird than saying 4.3 inches. It's kind of context with how you're answering the problem sometimes.
So at the end, if I get a decimal point that has, or if I get a number that has 3 decimal points, the like 1.125, would I just write 1.125, or would you want me to round that?
Yeah, I would probably keep it exact if it's just 3 decimal places.
Okay.
Yeah. If it's a whole bunch, I'd probably round it to 2 or 3 decimal places usually. You're pretty safe with 2 or 3 decimal places in general. Usually if it's off by more than that, you're in the wrong units. That's not, I want to do breakout rooms. Okay, so let's go to the breakout rooms and do those. Basically, there's 3 different little things. That one's matching, so I count that as one problem. And then we'll be back. We got a few minutes. I'll give y'all like 7, somewhere around there probably. We're getting pretty close to the end. What are the max and minimum speed limits along the stretch of highway? So we get this highway, y equals f of x is the graph. It gives our speed limit on the y-axis. And the x is the number of miles. So what is the max and min speed limit along this thing? Who's in my group? Let's look. Caitlin, Carson, Jana, or Michael? Should I get this one? So what's the max? What's the highest the speed limit goes? Reading this, which one is that? So my x variable or y variable? Speed limit should be my what?
The Y.
Yeah, the y variable. So what's the max?
55.
And the min?
30.
Yeah, that's right. Miles per hour, maybe. That's it. Estimate the miles of highway with a speed limit of 55 miles per hour. So how much of the highway has 55 miles per hour as its speed limit? How many sections do you see that have that? That's another way.
3.
There's 3 sections in here that have it, right? I'm looking at those three sections. And so how much is that? If we calculate it all together, how many miles is that talking about?
12 miles total.
Yeah, we're doing what, 4 by 3? Is that what you're saying?
Yes.
4 here, 4 here, 4 here. I believe there are a total of 12 miles of highway that have a speed limit of 55 miles per hour. Ooh, F of 4, F of 12, F of 18. Ooh, now they're being a little tricky, huh? It's not too bad. You get once you learn the little rule, I think it's all right. C says F of 4. So what is that talking about? What value is 4? What value are we plugging 4 into?
Miles. 40 miles.
F of 4 is, I think you said the right number, maybe. I like barely heard it.
40 miles
Per hour. Yes, that is correct for F of 4. I was asking, what does 4 get plugged into?
10 miles.
To your X. And so we're looking along here. And I think the thing that's going to trip people up is like, do I pick the solid circle or do I pick the open circle, right? Guess which one you're picking there. You said it right.
said in the notes that the filled in circle is the one that
That is the value at that point. Absolutely. If we look at this one, it goes up to 4, right? But it does not include 4, the open circle. It goes to like 3.99999 in there, something like that, right? It goes infinitesimally close up to it. But then once we hit 4, it skips down to what, 40? These should be in miles per hour, each of these things. When we give a Y value, it's going to be in miles per hour. So it looks like we have a 20-mile road or something here that's going on. And what is this telling me? Like 4 miles down the road, my speed limit is going to hit 40 miles an hour. I think this is the way speed limits work too, right? As soon as you hit that sign, it's that speed limit. Going up to it, and until we hit it, it's still 55.
Speed limits work. Speed limits work just like the lines at red lights. Technically, if your front wheels are over it before it's red, you didn't run it, kind of thing. So, yeah, if they clock the back side of your car over that, but your front wheels are past that sign, you're okay.
Okay.
Because you have to, round up for the whole vehicle.
F of 4, F of, what is it, 12 is another one, F of 12. I think these are all asking like kind of the same question, just with different points. They're really trying to make sure you understand if I go here at F of 12, or if I go here at F of, well, actually 18 is like right there, ain't it? So what is my F of 12? I think that one's at where? Someone was
Maybe 30.
Yeah, it'd be 30. We're looking here, we're looking along here at that point's 30. And what's that last one? F of 18. 18 is going to be like somewhere between 16 and 20. So if I plug in there, what am I going to get?
55 miles per hour.
55. Okay. Okay. And then now we get this interesting, like, at what points is it discontinuous? At a lot of points. So let's erase all this drawing I got on this circle. So at what X values is this discontinuous? So I'm going to do it like right in here. At what X values does this thing have a discontinuity. What does that mean? There's a few different ways to like define continuity. The easiest way, I think, is if you do what? Set it in the notes. Something about drawing with a pencil. If you have to do what?
Lift it up.
If you lift it up, that is a discontinuity. So where are we lifting this thing up? At x equals
4.
4 is one of them. Yep.
4 miles
X.
per hour.
X equals 4. X equals where's the next one? Between 4 and 8, right? Is that what you're seeing?
6 maybe.
6. That's what I'd say. And then another one at
8.
8. So I'm just looking along this line, and anywhere I have to pick up my pencil, I look down and I see what X value that is I'm picking my pencil up at. So 4 at 6, picking it up here, jump there, picking it up to jump there, picking it up to jump there, picking it up to jump there at where? 12, I think.
12.
And the last one should be
16.
okay. And so we said this was discontinuous because if I'm drawing this with a pencil, I have to pick my pencil up to draw it, right? Anytime you're breaking that graph, putting a break in there, that's a discontinuity. All right, so I know I didn't ask you to do it, but we're gonna do it right quick. Is that next graph? Is that continuous or discontinuous?
Continuous.
Do you have to pick up your pencil to draw it? You're right, it's continuous. You don't have to pick up your pencil to draw this. It should be continuous. What else did I sign? Where are we at? Ooh, I am like going over time. Didn't even realize it. All right, so we'll go through these 3 more that I have assigned. We'll do those matching right quick. Yeesh. So if you told me C on this one, I hope you didn't tell me C. I think C is the extra choice that we actually don't need, right? If we look where the graph is split, this is at -1, this is at 0, this is at where 0. That might give you a hint with some of these. That gives you one right away, I feel like, almost. If we know it's split at -1, what does that tell us about the piecewise function? You see where that lines up with one of those? Is there a piecewise where it's split about a -1?
Isn't that one 34?
34 is, right? This one right here, when we look right in here, this is the only one that's split about the -1. And does that look like what they're saying? It looks like the left side is a negative parabola, a -x². Like this side might look like a -x². And this side should look like x -2. Just knowing the basic sort of shape of these things. The x² create a parabola. The negative is going to flip it upside down. The absolute value, we talked about those things. It should look like a V. Does that look like a V?
No.
Yeah.
Yeah, so those look like they're matching up. It's split at -1. That left side looks like a downward parabola. that right side looks like an absolute value. So now we're just looking at these other two, and
35 is C.
yeah, 35. I think you said the wrong thing, but
C.
D, yeah, it should be D down there, right?
Oh, I'm looking at the wrong. Yeah,
Yeah, I think you were
I
looking
meant
at
D.
that thing right there, and you weren't looking at the right letter under it. The letter's under it, not on top of it. Okay, so I think we matched them all up, didn't we? And why are you saying that? Because if we look at this, this has something in there that looks like what, y equals 4 or something like that, right? And we know that those are constant functions. So this one, I think if you just think about these things are constant functions, y equals 4, y equals a minus 4. Those things should be flat. Should be the simpler graph. This one should be the more complicated graph. All right, so question?
I want to just make sure what's the number for this exercise. I was lost. I lost.
33, 34, and 35 are the numbers. I don't think 34 was assigned, but I threw it in there anyway. So 33, I believe, should be B, 34 was A, 35 was D. Okay, and then I want to do the last thing I want to do in class today is to graph one of those piecewise functions right quick. So which one did I say? I said what, 53, 49, that's what I said. So if I want to graph 49, what are the important points in my domain? That's what I want to get at first. So this is actually like 3 different functions, right? I have a y equals x. I have a y equals 1. Y equals x, y equals 1. And then I have this thing that looks like y equals what, 2 minus x?
Yes, 2 minus.
And so what are the important things? Where are we splitting this, I guess is the question, right? Where are those important points in my domain?
Minus 3, minus 5.
So at -3 at these points, right? -3, -1. -1 is repeating again there, the 1 in
And then
3.
minus 1, 1.
So I
And
want
then
to, I'm probably going to draw a little dashed line like along here. -1, that's -1, 2, 3.
Enter 1.
Have one along here at -1 here, it's going to split.
Mhm.
I have one at 1. Trying to do a dashed line on here. And then I have one at where? 3?
Yes, 1 over 1, 3. Yes, it's going down.
1, 2, 3. Ah, what is it doing? Don't do that. I believe it's like right along here. Okay, I think maybe if I zoom in a little bit more, it might actually be better. So -1, 2, 3, somewhere along here. Somewhere along here. and I'm doing 3 different functions. So if, let me bring this up on the other screen and I can look at it while I look at this. We are doing what, 49. So the first thing I want to look at is this y equals x function. And it gives me the x's between what, -3 and -1.
-1. Then it's constant between -1 and 1.
So what is the first thing I want to plug in? I want to find points.
0. No, sorry. It's -1.
This is the thing that they tell me about my domain. It's for x's between what, -3 and a -1.
Oh, yeah. Sorry. It's -3, then -2, -1, 0, 1.
So I want to know when x is a -3, what is my y? So I'm trying to find the point at x equals a -3. I want to
It's
also find this at x equals.
Yeah, when your x is equals to -3, the y is -3.
Yeah, so the y is a -3. This one, yeah, the x is equal, y is equal to x.
Mm-hmm.
And what's the other point?
-2, -2. Right?
So I want to find the endpoints of this line.
The inputs,
So one of the endpoints is where the x is a -3. The other endpoint is where the x is a
-1.
-1. And if the x is a -1, the y is also a
-1.
-1 because y is equal to x.
Right.
So if I go here,
Just
I'm looking here. This is a -3, -3. This is a point -1, -1.
Mm-hmm.
If I'm looking at the -3, is that a solid point or a hollow point?
It's solid point
It's solid. How do you know it's solid?
because it's inferior or equals superior or equals to x equal
Because it's
yeah,
less than or equal to, right?
yeah.
This one, it looks like it's underlined, but it's not. That's the negative coming out from that one. What about this one? Is that a solid point or a hollow point?
Which one?
The -1.
It's a solid point too.
It's hollow.
It's hollow because
it's
it
open.
doesn't. Yeah, it doesn't have the equal to. So
You
at a
have-
-3, -3, I want a solid. At -1, -1, I want a hollow.
Because I have it in my I put it with equals. For this one I said it's solid. Yes, okay.
Yeah, because it's strictly less than -1, right? So this one is not including the -1 in it. It's going to go right up to it. But it's not going to include it. So -3, let me do a different color, maybe blue. -1, 2, 3, -1, 2, 3. So I believe I'm talking about this point right in here. And I believe I'm talking about this point right here, but I need to have an open circle. And so how do I draw that graph? If you go,
Excuse me, teacher.
yes.
You said when it's the open circle for the -1 for the when if it's like x superior to -1 and inferior to 1, right?
So it's an empty circle because of the way that the domain's set up in this problem. So if we look at the -3, it has a less than or equal to on.
Mhm.
Oh no, it doesn't. You're right. I have it
Yeah,
drawn.
because I have it in my side with equals.
This
For
does have
one,
an equal to. Yeah, it should be. Sorry, I copied the problem down wrong, I think is what happened. Yeah, that is correct. It does have the equal to on that one. So if it has the equal to, it includes the point. So we're including both of these points. You're right.
Thank you. Because you are a teacher, and then when you said no, it's no.
Good call. I wrote it down. No, what happened is I wrote down the problem incorrectly.
Okay, no problem.
Yeah, but that domain absolutely says equal to. So it says x could be equal to that -3. It says that x could be equal to that -1. that they should both be solid points. And if you get your endpoints, all we're doing is drawing a line, right? These are all linear functions. They're not throwing us higher order functions yet. They'll do that like way later in the course. But they should either be like flat or they should be a line between the 2 points at this
It's a line.
junction. Yep. And if we look at it, right, y equals x is that line, right?
Mm.
It should be a linear function, y equals x.
Yep.
So that is the first line. The next line is,
The minus 1, 1.
yeah, y equals a minus 1.
Here it's open. It's not solid.
So we are literally drawing 3 different lines, but we're only drawing pieces of them, right? So y equals 1. And this is good for everywhere where minus x is less than, minus 1 is less than x is less than 1.
And here it's going to be flat.
So when my x is, what am I looking at? What 2 values of x do I want to plug into this thing?
Minus 1, 1.
Yeah, the things that say up there in my domain. So I want to plug in a minus 1. I want to plug in a 1. Those should give me my endpoints. So when I plug in minus 1 into my x, my y is
1.
1. And if I plug 1 in, my y is still just
1. It's the same thing.
So this should look like a flat line, I think is what you're telling me.
Yes, it's flat line and it's open in the minus 1, 1 and solid in 1, 1.
It's open, and what else?
It's open.
This
It's
one-
open bracket. Yeah, open
It
bracket.
should be open on both, right?
No. Because look, your function, you have x superior on minus 1 and inferior on 1. Do not have equals there.
Yeah, so there's no equals on either one of them.
Yeah.
So minus 1, the x cannot be the minus 1, and the x cannot be the 1, right?
Yep.
So it can never be these things. So it should be an open circle on both.
Yeah, open circle on both. Because you know why I said it's closed? Because when I did the third one, it's going to be solid. Okay, yeah.
They usually stagger them so you don't have like the same closed sort of thing happening. Like here we have a closed on that minus 1, right? Usually they kind of stagger these. I don't know if you noticed that. They usually kind of stagger the open and closed. So we go up to it in one of them, but we actually include it in the other.
Mhm.
Not always. Sometimes they can do weird things, but I think they try to do that. So that you don't have 2 values spitting out. And then it breaks the function if you do 2 solids over them, right?
Because when you are going to draw the third
Yeah,
line, it's
this
going
passed the vertical line test, right? It's not
Yes.
going to ever hit it twice. So I think that's why they like to do them kind of staggered like that. All right, so we graph those 2 things. There's one last thing we got to graph. So we graph the y equals x, we graph the y equals 1. The last thing we have to graph on here is that y equals
6 minus x.
what? No, you're looking 53. We're at 49.
Okay. It's 2x, 2 minus x.
2 minus x, that's it.
Yeah, sorry, because, yeah, sorry.
That's it. 2 minus x. Ooh, didn't even write that correctly. Let me rewrite that. 2 minus x. And this is good for all x's from 1 to 3, including?
Yes, including both of them.
Including both of them. And so I want to start out at x equals, and I want to also do x equals what numbers? What x is what?
When your x equals to 1, y equals to 1.
Yeah, I want to do 1 and
1, 1.
And yeah.
You are going to have 1, 2, and 3 for your x's.
For my x's, I want to do the endpoints. I want to do x equals 1, and I want to do x equals
to 2 and x equals to 3.
You can do 2. I don't think you need to do 2 though.
Whatever, because you have 3 points there.
Yeah, that would give you more points. It's not a bad idea, but here I would probably just do the endpoints.
Okay.
So 2 minus 1 is 1, and you said what? 2 minus 3 is a
It's 2. No, sorry, 2 minus 3, it's minus 1. Oh,
minus
man.
1. There we go.
Sorry.
And so I want to draw this, and these endpoints are they solid or are they empty, hollow?
Solid.
They are
Solid
both
or-
solid, right? They are both including
Yes.
here and here. They're both including. These are solid. These are solid. We're doing 1, 1.
Yeah. Mhm.
So I think we're taking over where this guy left off, right? We're making this one solid now. At
Yeah,
1,
this
1.
one is before. Yes. Now it makes sense.
And we go 3
3 minus 1.
minus 1. And so we're drawing the line between these 2 points.
Yep.
Is that a continuous function? I think that's the other thing they ask.
No.
No. It's not continuous because of like
Of
this
the
thing
first
over here.
line.
Yeah, this first one over here. If it was just that second part, it would be continuous because it picks up where the other one left off.
Because it's not continue on its domain. It's like it's discontinuous. Okay. Yeah,
Yeah, that's it.
thank you.
All right, so we are definitely past time now. But if y'all got questions, I'm here.
Oh man, it's too open. Thank you so much, Nico.
Sure.
Okay, have a good day.